Hello, guys. Welcome to another episode of Cuda Education. Um, today I want to talk about just an overall mental model of how all of this works. Okay, so we sort of dived into code in the previous video. This video is just about doing a framework of how all this stuff glues together. Okay. Um, so the first thing really is that we have our Mac OS. The Mac OS, of course, is the operating system. So the operating system um, boots up the application. Really and truly, it's this thing called Coco. So this Coco thing right here, this is the behind the scenes maestro of all things OS, Mac OS, right? Operating system. So Mac OS boots the app, creates the window and view, right? Then MTK view asks its delegate to draw. The delegate forwards to the renderer, and then the renderer produces a frame. Okay. Um, so let's just kind of on a high level. We have our application. We have main, which is what we're in now. So we have we have this thing called Coco, which it basically runs for Mac OS, right? So notice that it's part of the else branch of this if statement, right? So it runs on Mac OS, and it's the behind the scenes maestro, right? So of course for Mac OS we run this thing, as you guys know from the previous episode, um, and it runs, right? So we have seen, so macOS boots the app, creates the window and view. So we have we have view controller and all that stuff, right? You guys remember the view controller. We have this guy here. Creates a window and view. MTK view asks its delegate to draw. We saw in the view controller, we talked about the delegate. So we had a is it here? Right, we had the delegate conversation. So again, macOS boots the app, creates the window and view. MTK view asks its delegate to draw. So the delegate is now what basically acts right. MTK view asks the delegate to draw, and then the delegate forwards to the renderer. So here in the delegate, you see that we decide a metal device that's going to be able to render. So the delegate basically goes to the renderer, and you guys remember we had our metal for renderer or our regular renderer. The delegate forwards to the renderer. The renderer produces a frame. Okay. So there are a couple of structural things that we need to basically cover. The main approach of how the Mac OS and the renderer works is, and the metal renderer works, is that it's basically the operating system asking for a frame, right? That is the paradigm of metal. So the operating system, or the paradigm of Apple, the operating system, through its views and the MTK view and all that stuff, asks for a frame, and that's the only piece where we start to get into the render conversation. Okay, so metal isn't the whole system. Metal isn't the whole application. All metal is really is the portion of the conversation that deals with the operating system asked for a frame, and the renderer now, whether by whether by Metal 4 renderer or regular Metal renderer, is going to produce this frame that was asked for. That is the paradigm of how all this works in Metal. Okay, you know, in different graphics APIs, it's a different story, right? There's no eternal loop that Metal runs on, and you know, Metal controls the show, and Metal decides things. No, it's the operating system that sort of requests a frame in a nutshell, and of course the sort of the maestro behind it is this Cocoa thing application, right? Um, so we have this thing of a view controller. So I believe that the window and the view, we have the view controller, right? So in the bigger scheme of the project, we have all these different subheadings, right? Obviously, application is where the main thing happens, but then we have the view controller, shaders, Metal 4 renderer, Metal renderer, renderer common, all of that stuff, right? But the view controller does not create the window or view. It is handed a view that already exists. Okay, so what I interpret that as is that the view that already exists really is coming from the the OS. So what really happens is that even when we disable, so let's disable the delegate, I mean the renderer. Even when we disable the renderer, my system is going to run on this branch of the tree. Even when we disable the delegate, I mean the renderer, we're going to see that basically all right, we're going to see that basically we just get a window. We get a window with a label, min max, you know, expand, all of that. We get a window with a label, right? But metal isn't really doing anything because the renderer isn't being called, right? So the window and the shell of the window, you know, of the application and all that is really done natively by the OS, right? It's not really, you know, Metal hasn't really done anything yet because it's not rendering anything. So this underlines the idea that you know, now we get our triangle because the renderer is rendering. So this is Metal, but everything around it is not Metal. Okay, so this underlines the idea that the window and the view. So again, macOS boots the app, creates the window and view, right? The window and view is really macOS. It's not Metal itself. MTK view asks its delegate to draw. The delegate forwards to the renderer, and the renderer produces one frame, right? So this renderer is really where the Metal lives. And of course, you remember from the previous episode, we can decide whether to use a Metal 4 renderer or a regular Metal renderer. So the view controller wires things together, takes the existing view, an MTK view, gives it a device, right? So the view controller the view gives it a device, creates a delegate, so sets the view's device property to the system's default Metal device, right? So you can see here, even in the language, that the view is already created. And then now we have to assign a Metal device to actually do the drawing. So the view controller takes the existing view, gives it a device, right? Creates a delegate, right? And assigns a delegate to the view. We'll get into the assignment, the delegate to the view. So view.device, and basically, we assign the delegate to the view, right? The view controller's job is wiring. It's not viewing, okay? So that's sort of the mental model for the what the view controller does. The view controller, again, all the view controller does is it's the wiring, right? It takes the existing view, gives it a device, creates a delegate, assigns a delegate to the view. Okay? Now, let us dive into the the MTK view, right? Right, the MTK view is the OS managed drawing surface. Knows about display refresh, knows when it needs a new frame, and does not know how to draw your content. So the MTK view is not, you know, it's not drawing itself. It just knows about the display refresh, knows when it needs a new frame, and does not know how to draw your content. MTK view, when it's time to draw, I'll call my delegate. So you guys understand now that the MTK view has to call its delegate, right? Call its delegate in order to basically initiate getting the frames. MTK view pulls frames. Your code does not push frames. So basically, the MTK view is what is requesting. The MTK view is what's requesting frames. So let's do the big picture again. macOS boots the app, creates the view and window. MTK view asks its delegate to draw. The delegate forwards to the renderer. The renderer produces a frame. Okay, so that is sort of the hierarchy. The delegate is the bridge between the OS and your renderer. Okay, so this is like United Nations stuff, right? The delegate, the bridge between the operating system and the renderer. Okay, that makes sense because the MTK view calls a delegate, and then the delegate, asks the delegate to draw, and the delegate forwards the request to the renderer, and the renderer produces one frame. So the delegate is the bridge between the OS and your renderer. MTK view delegate, receive draw callbacks from MTK view and forward them to renderer, right? So that is again what the delegate does. So when the OS decides a frame is needed, metal kit view delegate right. So when the OS decides a frame is needed, empty metal kit view delegate draw in MTK view. Right, it basically reaches out to the renderer, notifies the system when the system is ready to draw a frame into a view. Right, so notifies the renderer that, hey, we're requesting a frame, and the renderer basically gives you that frame. So this draw in MTK view is called by the OS. It is not a loop. It is not scheduled by you. Okay, so this gets back to the idea of, there's not an internal loop running in the background that basically generates frames automatically. It's the operating system that basically requests frames. Now, it might request many frames, but again, Metal itself is not running, is not running the show. Metal is just the renderer. Okay, so that's sort of a key structural constraint on how you think of Metal. Metal is just the renderer. Okay, right. So the renderer is how one frame is produced. Metal for renderer render frame to view. So render frame to view right here, right? This function is called once per frame. It must prepare data, describe drawing, submit work, return. Okay? Render frame to view is not continuous execution. It is a reaction to a draw request. So again, I'm highlighting what I said before. It only does this if it's being requested to do so. It doesn't automatically run as a for loop, an eternal for loop. After this returns, the OS is back in control. The renderer is idle until the next callback. Okay? So that is sort of, we need to fully understand what's happening and how Metal runs. So again, it's a OS that kicks off everything with its Maestro Coco. So Coco, is sort of managing everything on behalf of the operating system, Mac OS. And then the Mac OS creates the window and the view. We saw on many occasions, both in this episode, and especially in the other episode, we saw where the window and view is created without anything inside of it when we turn off the renderer. And that's sort of driven by the operating system. MTK view asks its delegate to draw. Right? MTK view asks its delegate to draw, and basically the delegate forwards to the renderer, and the renderer is what actually produces the frame. Okay, the view controller wires things together, takes the existing view, gives it a device, creates a delegate, assigns the delegate to the view. The view controller's job is wiring, not viewing, okay? And the MTK view is an OS-managed drawing surface. Knows about display refresh, knows when it needs to draw a new frame, does not know how to draw your content. MTK view, when it's time to draw, I'll call my delegate, okay? MTK view pulls frames, your code does not push frames. So it's not like the code is just generating frames and pushing it to the screen. Right? It literally pulls frames because it's requesting frames. The delegate is the bridge between the operating system and the operating system and the renderer. Okay, so right, the bridge is between the operating system and the renderer. So MTK view delegate receive draw callbacks from MTK view and forwards to the renderer. When the renderer decides to draw a frame, it calls a draw in MTK view, and then goes to the renderer for the actual frame. Okay, so so I just want to also, while we're on the topic, let's get back to main. So we have the Mac OS, and then from the Mac OS we have NS application. And notice here we have this thing called NS application main. This is the event loop, right? So this is the event loop, but notice that it's basically, we haven't even mentioned Metal yet or anything. This is just the event loop from sort of the operating system. Okay, so we have the NS application, then we have the MTK view, which knows when to draw. So the MTK view knows when to draw. Then we have the drawing MTK view. That is the OS callback, the operating system callback, right? And then we have the render frame to view, your frame logic, right? So so again, we have the Mac OS, we have the NS application, which is the event loop. We have the MTK view, which is know when to draw, MTK view. Then we have the drawing MTK, which is the OS callback, notifies the app when the system is ready to draw a frame in view, right? And then we have the render frame to view. So this is actually where the rendering gets done, and that's where your frame logic lives. Okay, so it's OS MTK view delegate renderer. Okay. Let us also just get back to, we'll just do a deep dive into you know high level stuff, because I don't want to get too intricate and too deep into it, and we don't really fully understand what all the moving pieces are. So we have the app life cycle, or the app lifetime. Who owns it? The Mac OS owns it, right? The app lifetime, the operating system owns it. Who controls it? The Mac OS controls it, right? The operating system controls it. So the operating system controls the app lifetime, and the operating system owns the app lifetime. The window, right? The window. So remember, sometimes we see the window without anything being rendered in it. Who owns that? That is owned by the Mac OS, the operating system, and also a thing called storyboard, which is just like sort of relationships to things, but I don't want to get into storyboard quite yet. But who owns the window? Mac OS, right? Who controls the window? Mac OS, right? So it's consistent with what we have said. All right, MTK view. Who owns it? Who owns MTK view? Well, the thing that owns MTK view is the view controller. So all the MTK view stuff you could see here is part of the view controller. Okay, so the view controller owns the MTK view stuff. Okay, who controls MTK view? So who owns it is the view controller, but who controls it is, of course, Mac OS. All right, so we get to our delegate. Okay, so the delegate is sort of a sub thing of the MTK view. Who owns it? Who owns the delegate? The view controller. And who controls the delegate? Well, the delegate is controlled by MTK view, right? So remember, MTK view calls this delegate when it needs to get something, get a frame from the renderer, right? So the delegate is sort of the middleman. So the delegate is owned by the view controller, but it's controlled by the MTK view. All right? The renderer. All right? Who owns the renderer? Well, the renderer, in terms of like immediate superior, is the delegate, right? So the delegate basically is the one that ultimately says, hey, renderer, we need a frame. And then who owns, right? So the delegate owns the renderer, and who controls the renderer? Well, the delegate also controls the renderer, right? And of course, it's a cascade, right? But the renderer is basically the sole domain of the delegate. All right. Frames. So these frames now, who owns the frames? Well, the frames are owned by Mac OS. So the operating system owns the frames. Who controls the frames? Mac OS controls the frames. I mean, that one, it's just, I guess, right? But the frames are owned and controlled by the operating system. When we talk about a frame, I guess we're talking about in here, right? Because this is a frame, but this is the window and view. This is the window and view, but this is the frame, the actual rendered triangle and stuff. All right, so one other thing that you guys need to understand, very important. You never control the main loop. You only respond when called, okay? So you, as the author of this whole show, as a developer, you don't control the main loop. You only respond when it's called. So you could control what the response is when called, but Metal doesn't control the main loop. The operating system does. And you decide what the frame logic is in the render frame to view stuff. You decide what the frame logic is, and that's that. So let us do a little bit of double jeopardy. But let us do a little bit of a game. So what happens if we take out, if we get a a sharp knife and we take out the view controller. So if we take out the view controller and the view controller wiring, right? We're all engineers and stuff, guys, right? If we take out the view control wiring, what happens? What would happen? Well, we'd still get a window. We'll still get a window because the window again is basically generated by the Mac OS operating system, right? The operating system. So we'll still get a window, but we don't get any rendering, and the MTK view has no delegate. So obviously, just like looking at the file structure here, you could see that the delegate stuff is under the view controller thing, right? So we get the window, we get no rendering, and we get the MTK view has no delegate, which makes sense because if you don't have a delegate, you don't have any way to call the renderer. But you will still get your window because the window is controlled by the Mac OS. Okay. All right. Let's move a step further. What happens if we don't have any? What happens if we don't have any MTK view? If there's no MTK view, MetalKit view, right? If there's no MTK view, there's no draw callbacks, and basically what that means is that nothing ever asks for a frame. So remember that in the cascade of things, the MetalKit view is what decides, is what is part of the chain of going to the renderer to ask for a frame. If you don't have an MTK view, you don't get a draw callback, and nothing ever asks for a frame. So you don't get a frame, right? And that's just it, right? No delegate, no frame, no nothing, right? All right, so next thing now. What if we have no delegate? If we have no delegate, we sort of have a break in the chain of command. So we might have an MTK view, but the MTK view has no delegate. So the MTK view wants to draw, but it doesn't have the delegate in order to basically go to the renderer to ask for a frame. So the MTK view wants to draw, but nothing is drawn because, the renderer doesn't know that MTK view wants a frame because there's no delegate. Okay, so I'm gonna assume you get a window again, but nothing rendered, right? That's my assumption, right? What happens if the delegate doesn't forward? So if the delegate doesn't forward the request to the renderer, what happens? The draw callbacks happen, but the renderer never runs. So, I mean, this draw callback thing is a weird whatever. But basically, the delegate is it's almost like someone leaves a message with you to tell someone else, and you never tell the other person the message, right? So you eat the message. So the draw callbacks happen, but the renderer never runs, right? Because the renderer never knows that a frame was requested, right? The delegate is not forwarding the message to the renderer. What happens if the renderer returns early? If the renderer returns early before running your frame logic, like for example rotating a triangle, the app runs fine, but the window stays blank because the renderer hasn't gotten a chance to render anything. So it just stays blank. Okay? Let us go quickly to Cocoa again. So import Cocoa. And notice import Cocoa is for basically, if you're not iOS and you're not tvOS, then you're Mac OS, which means you have to run Cocoa, right? Cocoa is the Mac OS native application framework. It is the system that creates windows, handles events, manages views, and calls your code. Your Metal Triangle app is a Cocoa app that happens to render with Metal. I'll repeat that. Your Metal Triangle app is a Cocoa app that happens to render with Metal. Metal plugs into Cocoa. So I keep saying that Cocoa is the coach and the maestro behind the scenes. It really is. You're actually running a Cocoa application, but that doesn't sound well. It doesn't have a nice ring to it. You know what I mean? Listen, I want to say I run a Metal app. I don't want to say I run a Cocoa app. It just doesn't sound right. It's a little bit off, right? So people say they run a metal app, but really and truly it's a Cocoa app you're running, and it just uses metal to render the frames, to draw the frames that we need. All right, guys, so that is the lesson for today. Do I want to get into this extra piece of stuff? I will real quickly, just because it's really quick, right? So we have the NS application, which owns the app lifecycle. Then we have a thing called NS window, which owns the window. Then we have NS view slash NS view controller, owns the layout and hierarchy, right? And we have MTK view, a specialized Cocoa view. Okay, so now we know MTK view is a specialized Cocoa view. Metal, it only draws inside the view. So as we've said already, you know, the metal only draws inside of the window, right? That's all it cares about. You want a frame, I give you a frame. And then the frame is being put inside the window, and that's how we see the triangle inside of the window. MTK view is a subclass of NS view. Okay, so again, NS view slash NS view controller owns the layout and hierarchy. So MTK view is a subclass of the NS view. All right, so this is Cuda education, guys. I hate to sound like everyone else on YouTube, but please support the channel, support the content, like, subscribe, tell your friends, get people in your community together to work on this stuff. I'm sure a lot of you guys have Macs, okay? Get your friends together and say, hey, especially if you have a friend that's artistically inclined, guys, if you have a friend that's artistically inclined, get them involved in this stuff. I'm starting from scratch. Like, I don't assume any programming knowledge. I don't assume any knowledge about anything. If you know how to use a mouse, okay, and you know how to type on a keyboard, you can do this stuff. So be the leader in your community. Get everyone together. You know, time is expensive. It's 2026. Learn something new. Even if you, and later on in life, you do something else in programming or just in general, systems, processes, procedures, you know, learning how to code, or how things run, you know, what things happen, how apps are developed. It's all good information. You can't lose with this stuff. So, you know, support the channel, like, subscribe, tell your friends, view the different videos. You know, encourage anyone that is artistically inclined, that's creatively inclined. You know, I focus on the programming stuff, but I'm not about to start creating the next avatar. It's not my wheelhouse. But you might know people who are creatively inclined, so they will spend time, you know, making a triangle that's way more beautiful than this, or, you know, having some 3D spinning triangle or something, right? And it's like, ooh, whatever. So be the leader in your community. You know, take full advantage of time. Don't waste time. Time is expensive. And learn this stuff. It's all cool to play around with the gadgets and stuff, but learn how some of this stuff works. This is Cuda Education. Thank you for watching. I try to upload this content fairly frequently, so every day I just try and move the needle a little bit more. Have a great day. Goodbye.